And I want to change that to degrees. Well, I'll use the same kind of conversion. 180 degrees is pi radians. How many degrees is negative pi over 4 radians? Let me do a little cross multiply here. D times pi is 180 times negative pi over 4. I can divide both sides of this equation by pi, or multiply by 1 over pi, same thing. And my pi's all get to cancel. No pi for you. And my number of degrees is negative 180 divided by 4, but that fraction will simplify to what? 180 divided by 4 is 45, so this is negative 45 degrees. It's the same thing as negative pi over 4 radians. Okay, so you can use these kinds of conversions, or let me just put it all back on the unit circle for you so we can do things like we did yesterday. So I'm going to do, first I'll do the 45, 45, 90 markings around the unit circle. So I'll put my degrees, 0, 90, 180, 270. Now I'm going to put some divisions in between those. If I call out 45 degrees from standard position, I'm going to write that 45 degrees right here. And now I'm going to clock my circle off in 45 degrees. 0, 45, 90. What's another 45 degrees? Or the number right in between 90 and 180. 135. Then we have 180, and now let's clock off another 45 degrees. What's 180 plus 45 degrees? 225. Then 270 is another 45 degrees, and another 45 degrees from 270. 315. Okay, so I've marked all the 45 degrees around this, and now let me mark off all the radians that match those. Okay, 0 degrees is 0 radians. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. Now what should I mark with the 45 degrees there? I'm going halfway between 0 and pi over 2. What's going to be halfway between 0 and pi over 2? Or what's halfway between 0 and 1/2 pi? 1/4. 1/4 is exactly halfway between 0 and pi over 2. Oh, I'm sorry, 0 and 1/2. And so 1/4 pi, better known as pi over 4. All right. So let me go around the circle. 0, 1/4 pi, 1/2 pi. What's my next marking at 135 degrees going to be? 0, 1/4, 2/4, 3/4. 3 pi over 4. 4/4 is my next mark, and 4 over 4 is 1, so 1 pi. I know I'm in the right place. Next marking is going to be 5/4. Next mark should be 6/4. Let's see, 6 over 4 is 3 over 2, yeah, 3 over 2 pi. Next marking is going to be 7/4. So there's some exact radians to go with the 45, 90 triangles. Now, what is the cosine of 45 degrees? Remember to find the cosine. You make yourselves a little right triangle. And we find out the lengths of the sides. What are the lengths of the sides of this right triangle? Square root of 2 over 2. And square root of 2 over 2. Okay? The cosine was the x coordinate that is on the unit circle when I've traced out 45 degrees. So what is the x coordinate of this purple dot right here? Okay? So from yesterday's, we know the cosine of 45 degrees is the square root of 2 over 2. What do you think the cosine of pi over 4 radians is? It's in the exact same place, isn't it? So it's the same. What's the sine of 45 degrees? Same thing. So what's the sine of pi over 4 radians? 2 over 2. Okay. We'll do a harder one now. Let's go down to 225. Which other lines? Oh, all the divisions that I've made around the circle? So I put them on there to help me figure out where things are on the unit circle. So if I want to find the cosine of 225 degrees, it really helps me to know what quadrant it's in. Because I know the lengths of the sides of this little right triangle. It's the 45, 45, 90, so they're square root of 2 over 2. All right. What is the cosine of 225 degrees? Cosine is where I've come to get this green point, where I've come out on the x-axis. How far have I come on the x-axis? So what is the cosine of 5 pi over 4 radians? Okay. What is the sine of 225 degrees? I went left root 2 over 2 and down root 2 over 2 to get to the green dot on the circle. So what's the sine of 225 degrees? So what is the sine of 5 pi over 4 radians? So in other words, it may be easier to find cosine and sine when you're in radians by converting back to degrees and figuring out